Hey y'all. Um, so after the last 2 days of working on your tasks in class, I've realized that you guys um, are having some issues that I think we need to address. If I were there in person, I would be doing this in class, but since I am not there with you today, I'm going to work through this worksheet with you guys via video. Um, Pretty much everyone needs to be, not pretty much, everyone does need to be paying attention, because if you haven't come and gotten your paper checked with me in the last 2 days, it's because you didn't know what you were doing and you didn't have enough answers. And those of you who did come get your papers checked, there were several mistakes that you were making over and over again that hopefully throughout this practice we can address that. So you need to have your blue Z-score sheet out. Everyone should have that. If you don't have yours, there are still some in the basket. I took one this afternoon or yesterday, and for you guys, there are definitely still a couple in there. So you will need the blue sheet. You are going to need a calculator and obviously something to write with. So be sure that you guys have all of the things that you need in order to do this. So I am just going to work through these with you. Number 1 says fill in the percentages using the empirical rule and answer the questions. All right, so the first thing that you've got to do is fill in your table using the empirical rule. Anytime you guys are doing problems like this, I would draw a big normal curve. If you don't have much room, use a separate sheet of paper. Like your task that you guys have been working on, you didn't have a ton of room, so you may want to use separate paper. But drawing one curve is not a bad idea to go ahead and list out your mean and your standard deviations when it is a context problem, especially. This one's not a context problem. So all we need to do is label the curve with my percentages from the empirical rule. So 34%, 13.5%, 2.35%, and 0.15% is this last little bit back there. So my normal curve is symmetrical about the mean. So remember I told you you have to have these percents memorized. If you can get those 4, then it's just the mirror image on the other side. So 34%, 13.5%, 2.35%, and you can't forget the 0.15. Okay, so if you remember, so between the first standard deviation, the 34 and the 34, that was 68% of data values. Then as you move out one more, that takes you to 95% of your data values. And then as you move one more, that's 99.7%. It's not the full 100. Remember, the area under the curve is 1 or 100%. You've still got to account for, you've got these 0.15% that are out here in the back. On your task, that 0.15 kind of messed some of you guys up on some of those questions, so just be careful. A says, what percent of data values fall between 2 and 3 standard deviations above the mean? Okay, so I'm going to the mean and I'm looking above between 2 and 3. Okay, so if I were to just, mark this here so I could see between 2 and 3, that's 2.35% of my data values. So like a data values, it would be a set. So 2.5% of the entire set would fall between 2 and 3 standard deviations. So what percent of data values fall below -2 standard deviations? So you find the -2, that's right here. I'm going to just kind of draw a piece there. And below, okay, well, you're looking at the 2.35% plus the 0.15%. If you need to plug that in your calculator, then plug that in your calculator. The more you work with these, you're going to start to realize exactly what those percents are when they're grouped like that, and you get 2.5%. Okay, and then what is the total area under the normal curve? Well, I've kind of just talked about that. It's 1 or 100%. All right, so number 1 shouldn't have been too difficult. It's just making sure that you guys know the percents that are on that normal curve. All right, so number 2. Suppose the average age of retirement for the entire population in a country is 64 years. The distribution is normal with a standard deviation of 3.5 years. All right, so you've got a curve, so you always want to just fill it in, especially if you've been given the curve, you want to fill it in. So the average age is 64, so the mean is 64, so that goes in the middle of your curve with a standard deviation of 3.5 years. So you're going to, as you move from the mean to the right, you add 3.5 every time. So 64 plus 3.5 is 67.5. 67.5 plus 3.5, 71, plus 3.5 is 74.5. So then to move to the left, you're going to subtract 3.5. So 64 minus 3.5, that's going to give you 60.5. Subtract 3.5 again, you get 57. And then subtract 3.5 again, you get 53.5. Okay? So before I do anything else, I'm just going to kind of examine my questions and see if this is going to need the empirical rule. What is the approximate age range in which 95% of people retire? Well, hey, 95%, my empirical rule is 68, 95, 99.7. So I can use the empirical rule here. So I'm going to go ahead and I'm going to fill in my percents because I know I can use the empirical rule. If I can use the empirical rule, I'm going to use the empirical rule. Oops. So 34 is going in the middle, then 13.5%, then 2.35 as you move out one more, 2.35, then 0.15 is the last one. You can't forget that guy. All right, and then if you wanted to label the 68%, then we move to 95%, and then we move to 99.7. I don't know why that box keeps selecting there. Now it's selecting everything. There we go. Okay, so what is the approximate age range? So some of you guys were struggling too with an age range. Well, the age range is just asking from what to what. Okay, so what is the approximate age range in which 95% of people retire? Well, that would be from, you find the 95%, 57 to 71 years of age, right? Okay, so then what percent of people retire before 64? Well, look, 64 is an exact value right here on your normal curve, okay? Before 64, that's going to be really anything from here to the left. Well, if that's my median, or not my median, my mean, that's the middle, then it's splitting the data into 2 equal parts. So I'm going to get rid of that shading. So that means what percentage? Well, that's 50% because it's halfway. So C says what percent of people retire after 71 years? So you find 71. After 71 would be over here to the right. You can add those exact values right there because 71 is an exact standard deviation. You don't have to go find the z-score. So the numbers on the bottom are your standard deviations, and this 71 is an exact number there, so you could just add those percents. So 2.35 plus 0.15, and you get 2.5%. So when your values are on your axis, you don't have to plug them in and do the z-scores. That's just too much work. If you can use your normal curve and the distributions from the inside in here, from the empirical rule, then that's what you want to use. So on your task that you've worked on the last 2 days, those first 2 problems are for sure using the empirical rule, just like these right here. Okay, so number 3. The mean life of a battery is 50 hours with a standard deviation of 6 hours. The manufacturer advertises that they will replace all batteries that last less than 38 hours. If 50,000 batteries were produced, how many should they expect to replace? Okay, so the average life is 50 with a standard deviation of 6. I'm going to just go ahead and take that, and I'm going to draw a curve with those data values. All right, so the average is 50. So I've got my axis with my 50, and I know my curve's going to just do it the best you can. Okay, so 50 is in the middle of my curve, and I'm going to add 6 as I move to the right. So 56, I add 6 more, that's 62. I add 6 more, that's 68. So I'm going to subtract 6. So I get 44, then I get 38, then I get 32. Okay, so it says the manufacturer advertises that they will replace all batteries that last less than 38 hours. Okay, so if batteries last less than 38 hours, they will replace them. Okay, so, well, hey, 38 is an exact standard deviation right here, right? So I'm looking at from that 38 over here to the left side. Well, I didn't fill in my 34, 13.5, 2.35, but you guys ought to be at a place where you should hopefully be able to figure out what those percents are from drawing the curve so much, but if not, you can always go in and you can add it in, and I'll do it right here with the red. This would be 34. I just didn't draw it very good. 13.5, 2.35, 0.15. So those bottom two sections and the top two that we did just a second ago, those are always the 2.35 and the 0.15. Those are going to add to 2.5%. So on average, 2.5% of batteries have a lifespan of less than 38 hours. Okay, so the manufacturer can expect to replace 2.5% of the batteries. Well, then their question throws in, if 5,000 batteries were produced, that's like your population, right? So basically what we're saying is 2.5% of the 50,000 are going to have to be replaced because they are below 38 hours. Okay, so 2.5% as a decimal is 0.025. The word of means multiply times the population. 2.5% of 50,000, so you're multiplying. So when you do that, you end up getting 1,250 batteries. So you have several problems on your task where you have to find that percentage and then take the percentage and multiply it by the population that they gave you. Okay? And guys, at any point, if you get to a point where you're not real sure what happened, this video is posted on the web page, on the Advanced Algebra page, just right on the page when you get to it. I'll add it to the Unit 7 materials so that you can go back and get to this if you need to. Okay, so numbers 4, 5, and 6. Find the area under the curve for the given z, values of z. Assume the mean is 0 and the standard deviation is 1. Okay, so we're assuming we have a mean of 0 and a standard deviation of 1. The mean goes in the middle, 1, 2, 3, -1, -2, -3. And if you wanted to, you could just go ahead and label, because all of these are the same. They're all, I don't know what happened there, it just moved everything. I'm just going to go ahead and label all these. Okay, so 0 is the mean and standard deviation is 1. You can't assume that unless it tells you that. The context problems generally are all different and they're not just 0, 1, 2, and 3. Okay, so remember, your Z table, that blue sheet that you have, gives you the area to the left. So that table, the blue sheet, gives you the area to the left of a Z-score. Okay, so number 4 says find the area to the right of 1.16. So 1.16 would probably be somewhere right about there, just to the right of 1 a little bit, and it says to the right. I'll just say that Z, that doesn't like a Z, equals 1.16. When you know your Z-score, that's when you go to your table and you find the value. So on your blue sheet, everybody grab it, and you are looking for, on the left side, you're going to go down to, you're on the positive side, you're going to 1.1 on the left, and across the top, you're going to 0.06, and you're going to follow over and down until you find the correct percentage there. Okay, when you do that, you get 0.8770. Okay, so let's think about it. That's 87.70%. Well, is that little section that I shaded in right there in purple 87% of that curve? No, so that should be a red flag to you right away that, hey, I think something, I'm missing something, I'm forgetting something. Well, remember that 0.8770 is the area to the left. So that is actually this part right here. But what you need is this other part. So remember we said that the area, the total area under the curve was 1. When we did this in class, remember I said, hey, what if we pretended like that was y? You could set up that equation and you could say 0.8770 plus y equals 1. And then we said we'd solve for it. So it would be y is equal to 1 minus 0.8770. Okay, that's basically what you got to do, right? When you find the area to the right, you do 1 minus the table value that you get. Okay, so when you do 1 minus 0.8770, what you end up getting is, I'm going to come back up here, this area right here is going to equal 0.123 or 12.3% of my data. Okay. All right, so number 5 says find the area to the left of z equals negative 0.48. So negative 0.48 is probably going to be somewhere close to that. And it says to the left. Well, hey, to the left, then we find the value on the table and we use that one. So on your z table, you're going down to negative 0.4. You're going over to 0.08. Okay? Negative side of the table, you got to be careful. All right? When we do that, you should get 0.3156. Or, to change it to a percent, you move the decimal 2 to the right, 31.56%. And that's number 5. Number 6, find the area between 1.5 and 3. Well, there's 1.5. It's about right there. There's your 3. That's an exact standard deviation. Well, I can figure out between 2 and 3 exactly what that is. But between the 1 and the 2, that might be a little bit hard. I know it's going to be exactly halfway, but I'm really going to just go ahead and use my z table. Okay, since I know the z-scores. So for the first one, it's the 1.5. Remember what happens. That gives me the area to the left. So when I do, on my z table, when I go down to 1.5, I'm going over to 0.00 across the top. Right, on the positive side, that should be the first column if I remember correctly. Yeah, the very first column is the 0.00 there. So when you go to 1.5 and then the 0 at the top, you get 0.9332. Well, remember, that's the area from right here over, right? That's 0.9332. But I needed that green shaded area, okay? So I need to go to the table again, and I need to do the same thing to find from 3 over to the left. So that's just a z-score, that 3 right there, that's 3 standard deviations. That means that z is 3.00. So I go to 3.0 and 0.00 at the top on my table. All right, so 3.0 on the left, 0.00 on the top, you get 0.9987. So this purple stretch is 0.9987. Well, the purple is from the 3 to the left, the blue is from the 1.5 to the left, and remember, when we do area between, I told you guys you do big minus small, okay? The big area is the purple one, and we're going to take away the blue area. So 0.9987 minus, I'm running out of room, 0.9332, okay? So when you subtract those, punch those in, you should get 0.0655, which is equivalent, when you move the decimal 2 to the right, to 6.55%. Okay? All right, so if we need to pause right here so you can just check these 3, just raise your hand and the video can be paused so that you can get caught up. Otherwise, we will keep going to number 7. So 7, 8, and 9 are application problems that are similar to those that you're doing on your task, just a little bit different. There are 2 semi-tricky questions on your task in terms of the worst gas mileage. Remember, bad gas mileage in a car means that it's low. Okay, so when on your task, just your hint right here, when it's asking you about the worst gas mileage, the worst percentage with a certain gas mileage, the worst gas mileage is going to be on the left side of your curve. Okay, and remember, percents fall below that bottom number on your curve, so you're not going to give a range. If you're trying to talk about the bottom of something, it's going to be from one value and below, because it's not going to have a stopping point on that curve, because that 0.15% doesn't have an end really. And then the reaction time problem. If it takes me 5 seconds to realize that I need to slam on my brakes in my car, and then I react quicker, a faster reaction time would be less than that. Okay, so a quicker reaction time is less than. So those are your hints on those 2 hard problems there. And I said it in class for a couple people, and so there it is again for you. All right, so you don't have a ton of room. I really don't have a ton of room on this smartboard. So we're just going to do the best that we can. I'm going to see if I can shift some of this down a little bit and have room to write. You do have at least a little bit of space to the left. So what I would do if I were you is I would just draw my curve, at least draw the curve and label the horizontal axis, so that you at least see what you're working with, so that you know, can I use the empirical ruler? Am I going to have to do z-scores every time? Okay, so for 7, 8, and 9, I would draw one big curve just so you can see what you're looking at, and then we'll draw individual curves for each letter. So it says a lineup for tickets to a local concert had an average waiting time of 20 minutes with a standard deviation of 4. Okay, there you go. You have an average waiting time of 20 minutes, so that's your middle value. And then you have a standard deviation of 4. So 20 plus 4 is 24, plus 4 is 28, plus 4 is 32. Y'all just do this on the left side. I had to use the top up here. 24 minus 4 is 16. 16 minus 4 is 12, and 12 minus 4 is 8. So I drew this so that I can reference these standard deviations. So A says, what percentage of the people in line waited for more than 25 minutes? Okay, so 25 minutes. I go and I look. 25 minutes is not up here, but it's over here to the right. I'm just going to draw me a little mini curve. 25, it's to the right of the mean, and I want to know more of my curve. That's not supposed to curve up that way, but okay, hold on. That was terrible. So 25, it is to the left of the mean. Right, I'm sorry. And I shade to the right because more than 25 minutes would be 25 and to the right. Okay, so I just shaded to the right. The table gives me the area to the left, so I know no matter what, I'm going to have to subtract from 1. Okay, 25 is not a z-score. So I can't go to my blue sheet because I'm not going to find 25 on there. So I have to use my z formula. You've got it written at the top, x minus, I don't know why it does that, guys, I'm sorry. X minus x bar, you see it at the top of your paper. X minus x bar, which is the mean, divided by the standard deviation. So I got to plug in 25. So I'm going to find the z-score for 25. So it's 25, you may want to write small, minus 20 divided by 4. All right, so this is where a lot of you guys were messing up on your task. You were getting the incorrect answers because you guys were finding your z-scores and you were not rounding correctly. All right, luckily when you do this, 25 minus 20 divided by 4, you get 1.25. There's no doubt about that. There's no rounding. That is 1.25. So in the grand scheme of things, like if you came up here, what this means is 25 would be right about here. All right, so if that is your mean, that's the special thing, 25, okay, what this means is 25 is 1.25 standard deviations away from the mean. That's the z-score. Remember we said z-scores are like standard deviations. So 1.25 is not the percent. The z-score is how many standard deviations you are from the mean. So I'm 1.25 standard deviations from the mean, and I can figure out the area to the left of that using my table. So that's what I'm going to do. You're going to go to your table. Okay, I'm not going to write like I was doing earlier. I'm going to go to my table, and I'm going to use that 1.25. So on the left side, you go to 1.2. Across the top, you go to 0.05. Follow it over and down to get the area. So what you should end up getting is 0.8944. Remember, that's the area to the left. I need the area to the right. So what I have to do in order to finish this problem is I have to do 1 minus 0.8944. The 0.8944 was the area to the left because the table only gives me area to the left. I need the right, so 1 minus that. And what you end up getting is that equals 0.1056. But the question says what percentage? So that is 10.56%. So what this means is 10.56% of the people in the line waited more than 25 minutes for their tickets. All right, so if it told you there were 300 people in the line, then it would be 10.56% of the 300 people in the line, and you would have to multiply. Okay, but A didn't ask for all that. All right, B. B says, what percent of people waiting in line? That doesn't make sense. We're waiting for less than 10 minutes. Okay, so less than 10. The question doesn't make sense. But we're talking about less than 10. Okay, so I'm going to go up. I'm going to just compare and make sure 10's not one of my values on my axis. So I'm just going to sketch a little curve. I got a 10. It's to the left of the mean. All right, guys, so think about this. If this is to the left of the mean, your z-score is going to have to be negative. Some of you guys worried today because your z-score was negative, and you're like, my z-score, it can't be negative. Well, yes, it can. If the mean is in the middle, z-scores above the mean are positive, z-scores below the mean are negative. Okay, so this 10 should have a negative z-score. So when you plug in 10 minus 20 divided by 4, you get negative 2.5, and I'm going to add a 0 because I know my z-scores on my table have to be to 2 decimal places. So what this means is 10, okay, and if you wanted to go back up here to my main one, 10 is about right here. This says 10 is 2.5 z-scores below the mean. So 1, 2, and I know 10 falls exactly halfway between 8 and 12, so that makes sense that it's 2.5 z-scores below, 2.5 standard deviations. So what I now do with that negative 2.5 is I take that and I go to my table. Flip over to the negative side, negative 2.5 on the left, 0.00 across the top. You should get 0.0062. That comes from your table. Well, does that work? Is that okay? Yes. My table gives me the area to the left. I wanted the area to the left. I don't leave this in decimal form because it says what percent, so I'm going to move my decimal 1, 2 to the right. That's kind of weird. So what it's going to give me is 0.62%. So what happens is I take that decimal 1, 2, and it ends up in front of that 6 right there. So 0.62%. So 0.62%, less than 1% of the people in the line waited for less than 10 minutes. All right, C, if 2,000 ticket buyers were in line. All right, so there you go. You've been given a population of people waiting in line. That kind of should be a hint to you that you're going to have to multiply by something. Okay, so if 2,000 ticket buyers were in line, how many of them would expect to wait less than 22 minutes? You don't do anything with that 2,000 until the very end. Okay, my key word here is less than 22 minutes. All right, so I'm going to go up. Is 22 one of my numbers? No. Okay, so I'm going to draw my curve. 22 is going to be a little bit to the right. So less than 22 is to the left. Okay, 22 is minutes waited, not z-scores, not standard deviations. So the 22, you have to plug that in. So z equals 22 minus 20 divided by 4. Okay, you could assume where that is. If 20 to 24 is, that's your 1, you can figure out 22 is right there, right? That's exactly halfway. So that's like a half a standard deviation. Okay, so I should really, when I do this, should end up getting 0.5. And when you plug this in, you end up with 2 over 4, which is 0.5. And I'm going to put a 0 because these scores are 2 decimals. Okay, so I take my 0.5 and I go to the table. You go to 0.5 on the left and 0.00 on the top. Follow them down. What you end up getting is 0.6915. Okay? All right, so here's what this means in words. In words, this means 69.15% of the 2,000 people in line waited for less than 22 minutes. Well, I need to figure out, well, what is 69.15% of 2,000? So you got to multiply. So you're going to do 0.6915. You're going back to the decimal form. Of means multiply times 2,000. Okay? So when you get to the how many's, you have to multiply by the population. So 0.6915 times 2,000, that's going to give you 1,383 people. So 1,383 people waited in line for less than 22 minutes to buy their tickets. Okay, so it's kind of fast. Again, this is going to be on the website, so if you need to go back, you can. If we need to pause right now for just a second for you to make sure that you've got these 3 written down, there should be enough time to just press pause right now for a minute or so to get caught up and then keep going. Okay, so we have 2 more problems, but multiple parts. Okay, so number 8. I'm gonna do what I did just then. I'm gonna move this down, so just bear with me because I want to draw the curve. You have room on the left again. You can go ahead and sketch yours too. Just do a big curve just to compare to it. In an Oreo factory, the mean mass of a cookie is given as 40 grams. For quality control, the standard deviation is 2. All right, so I'm just gonna go ahead and draw a curve. So the average mass of a cookie is 40 grams. And the standard deviation is 2. So we're going to add 2. 42, 44, 46. I'm going to hope when I get Oreos that the mass of mine is 46 grams. Hopefully that means it has more icing in the middle. I love them. All right, so now go down 2. So 38, 36, 34. Okay, you can do your curve. Doesn't have to be perfect, just so that you see. So I'm going to use that as a reference just to see if I could use the empirical rule, but if not, it also just lets me see where these values are falling on the curve. It's also going to help me see, well, if I get a negative z-score, maybe it helps me not panic too much because I can see, well, that's below the mean, so it should be negative. All right, so A says, what percentage of cookies have a mass of less than 35? Okay, so 35 is up there. That's way down there on the bottom, right? And it says less than, so that's to the left. So if I were to sketch that, 35 is way over here in comparison to my mean, and I'm less than that, so I'm to the left. That's good. My table gives me the area to the left, so I'm not going to have to subtract from 1. But I am going to have to be careful. 35, you cannot go to the table, the z-table, and find 35. 35 is not a z-score. 35 is a mass of a cookie in this problem. Okay, so I need to figure out what is the standard deviation. How many standard deviations is 35 away from the mean? Okay, so I got to find the z-score. So z equals 35 minus 40 divided by 2. Remember, these go to 2 decimal places. I haven't had to round any of these yet. We don't have to round this one either. It's negative 2.5, and I'm going to add the 0, but make sure that you guys are rounding correctly, okay? Anything 5 or above rounds the number before it up, okay? All right, so negative 2.5 is what you're looking at now on your table, okay? So use that negative 2.5 on your table, negative 2.5 on the left, 0.0 across the top, follow it, left and down, you should get 0.0062. And it says what percent? So I need to move my decimal 2 to the right. It's going to put it right there. So I get 0.62%. That's a very small amount. So it's probably good. Part B, it says what percentage of cookies have a mass between 36 and 45? So we got to do a little bit more work here because this is a between problem. Between 36, oh, that is an exact standard deviation, and 45, but 45 is not. So what I always do, if one value is at an exact standard deviation and one is not, I just use my table for both to be a little bit more consistent, okay? So I'm going to use my table for both. So when I draw my curve, I got 36 over here, I got 45 over here, and I'm looking in between those two, okay? So I have 2 values. I'm going to use the table for both of them. I'm going to start with 36. I worked this just earlier in the day on Wednesday, and there's not a ton of space right there, so you are going to want to write kind of small, but just where you can see what you're doing. So I'm going to find the z-score for 36. I should get -2, okay? And if you can look at it and tell. 36, it has a z-score of -2.0, okay? I know that. I can look at it. I can count it exactly. If you plug that into the formula, you're still going to get -2, okay? And we can make it -2.00. We know that that is the z-score here. So when you go to your table, and look, just real quick, go back up here. How do I know 36 is -2? Well, here's the mean of 40. 36 is 2 below, okay? -2.00. So you go to the table, -2 on the left, 0.00 across the top. You should get 0. Hold on, let me find what I got. 0.0228. So what that means is from 36 over, it's 0.0228. So now I'm going to do the same thing for the 45. Okay, that I do have to actually do some work. 45 minus 40 divided by 2. So you do need to find that z-score. You get positive this time, 2.5, and I'm going to add the 0. Your z-score is 2.5. That's 2.5%, or 2.5 standard deviations. Let's look back up here. 45 would be right here. That's 1, 2, and a half. Okay, 2.5 standard deviations above. So now I go to my table with the 2.5. So 2.50. You go to the table. When you get there, you get 0.9938. What that means is from 45 over to the left side, because it's the area to the left, that's 0.9938. 99% of your data is from the 45 to the left of that. So if you look at my colors, I have the purple and the red. Well, my shaded would be the red with the purple taken out of it. Okay, so the red, 0.9938 minus what I put in purple. Big minus small is what I told you guys it's always going to be. So 0.9938 minus 0.0228, and you should get 0.971, and it asks for the percent. So you move the decimal to the right 2. That's 97.1%. So 97.1% of all cookies made are between 36 and 45 grams in terms of mass. Okay. All right, so if you need to pause for just a second and do that, you might start running out of time. So far I'm at 42 minutes with this video. So we got one more problem, so there's not a ton of time left. All right, number 9. Let me move this real quick, hopefully. All right, so the monthly income of 5,000 workers, there's your population right there, 5,000 workers. I bet you're going to have some problems that make you multiply. So the monthly income of 5,000 workers at a Microsoft plant are distributed normally. Suppose the mean is 1250, the mean income is 1250, and the standard deviation is 250. Okay, so I'm going to draw my normal curve just so I can see it. And in the middle, I'm going to go sideways just because these are bigger numbers. 1250 is in the middle, and I'm going to do 3 to the right, and I'm going to do 3 to the left. So my mean is 1250, my standard deviation is 250. So as I move to the right, I'm adding 250 every time. So I get 1,500, then I get 1,750, then I get 2,000. So then to the left, I subtract 250 every time. I get 1,000, then I get 750, then I get 500. So I'm just going to have that so that I can compare to it, and I may end up drawing my own individual curves every time, and that's okay if you do. All right, so what percent of workers earn less than $1,400 per month? So you see, where's $1,400? Well, it's not on there. So if $1,400 is not on your curve, you have to find the z-score. Okay, So I'm going to find the z-score for $1,400. So it's $1,400 minus 1250 over 250. Okay? Ooh, I didn't draw my picture. Less than 1,400. 1,400 is kind of this way, to the right of the mean, and less than is to the left, right? Okay, that's good. That means I don't have to subtract from 1. So you do 1,400 minus 1,250 divided by 250, and you should get 0.60. We need z-scores to be 2 decimal places. Okay, so 1,400, what this means is 1,400, which is about right there, is 0.6 standard deviations from the mean of 1,250. Not quite 1, okay? We can see that where I put that red line. So now I'm ready to go to the table with that. So 0.60, you go to the blue table, 0.6 on the left, 0.00 across the top. All right, so it's going to give you a percentage. You should get 0.7257, and it says what percent. Another word for what percent is what probability. So on your task, you might see probability. I move the decimal 2 places to the right, and that's going to give you, that is equal to 72.57%. So 72.5% of the workers at the Microsoft plant make less than $1,400 per month. Okay, so B says what percent of workers earn between $1,100 and $1,550 per month? Between. Anytime I see between, I need to think big minus small. Okay, big minus small. So I'm looking at, for this, if you were to draw it, you're looking at 1,100 on the left, and you're looking at 1,550 on the right, and we're looking between this. Okay, so I'm going to do the first one. We're running out of time here, so I'm going to try to go a little quicker. So 1,100 minus 1,250 divided by 250. That's your first z-score that you're going to do. Okay, so when I do that, it's to the left of the mean, so it should be negative. You should get negative 0.60. Okay, so you're going to take that negative 0.60. You're going to go to the table. Okay, when you go to the table with the negative 0.60, you should get 0.2743. So that's just to the left of this right here, right? That's 0.2743 right there to the left of the 1,100. Okay, so then you need to do the same thing for 1,550. So 1,550 minus 1,250 divided by 250. Okay, so you're going to plug that into your calculator. 1,550 minus 1,250 over 250 to get that z-score. You're figuring out where does the 1,550 fall. You should get 1.20. It is 1.2 standard deviations above the mean. Okay, so I take that 1.20, I take that to the table, the blue sheet, positive side, 1.2 on the left, 0.00 across the top. You should get 0.8849 for that percent. And remember, you have to do big minus small. Okay, so what I'm going to do, hoping I can fit this right here, I'm going to do 0.8849, and I'm going to take away the 0.2743. Big minus small, because I need to get rid of the chunk that's not shaded. So when you plug that in and you subtract, you should get 0.6106, which is equal to 61.06% of your workers. So 61% of the workers earn between $1,100 and $1,550 per month. Okay, so if the bell rings and you don't get to these problems, You do need to try to finish these. Hopefully this has helped you some. So C and D are how many workers. Your final answers should not be in percents, but you should be multiplying these, okay? How many workers make less than $900 per month? 900 is going to be to the left of your mean, less than 900. 900 is a value. It's an x-axis. It's on the x-axis there. It's not the actual z-score. You have to find the z-score. 900 minus 1250 divided by 250. It should be negative because it's to the left of the mean. The z-score should be negative because it's left of the mean. Negative 1.40 is what you get. So I'm going to go to my table. I find the area. I use negative 1.40 to get the area to the left. So when you go to the table, negative 1.4 on the left, 0.00 on the top, you get 0.0808. Since I shaded to the left, then I don't have to subtract. So what this means, when I move this over, it means that 8.08% of how many total workers? 5,000, right? So of 5,000 fall in this category. So the way that that's going to be, you're going to go back to decimal form, 0.0808 of means multiply 5,000. So 0.0808 times 5,000, and it's workers. You want to go whole number. So you're going to get 404. Let me double check my math here. I don't know. I can't read my writing. 404. So 404, that's not good. 404 workers. Okay. All right. And lastly, D. How many workers make more than $2,100 per month? Okay. That's to the right. So you're going to have to subtract from 1. Ooh, that's a bad curve, but it's to the right. Okay. So Z equals 2,100 minus 1,250 over 250. So you find the Z score. It's to the right. It should be positive. Well, that's 3.40. It's 3.4 standard deviations above the mean. Okay. So I go to the table. I use the 3.4. Right. So when you go to the table, you use that 3.4. You get 0.9997. Well, hey, that is the area to the left, okay? That is definitely not what we shaded. So you have to subtract from 1 because this was to the right. The table gave me the area to the left. I've got to do 1 minus 0.9997. When you do that, you get 0.0003. That is a very small number. So in words, what that means, if you were to move that decimal 1, 2 to the right, you get 0.03% of the 5,000 workers. That's not much at all. 0.03%. Like, that's not even 1%. Okay? So when you use this decimal to multiply, because you have to go back to decimal form, 0.0003 times 5,000, we're talking about people here, okay? So when you do that, 0.003, 3 zeros, 0.0003 times 5,000, you get 1.5, which is approximately 2 workers. Okay, so hopefully this will help you guys moving forward. As we seem to struggle with the task a little bit, you need to get that task finished up and get it turned in to me so that I can give you a grade for it. I will see you tomorrow.